Hi and welcome in this tutorial. Modern cloud-native applications frequently need a way to share data across multiple services. Azure Container Apps, Microsoft Serverless Container Platform makes it easy to run microservices, but each container has its own ephemeral file system by default. The moment a container restarts, any local written file are gone. Azure File Share solves this problem by providing a managed cloud-hosted SMB file system that can be mounted into one or more containers simultaneously. Because all containers read and write to the same network-attached volume, data created by one service is immediately visible to another, even if they are completely independent applications. This tutorial walks you through a practical example, which is two .NET minimal API services running in the same Azure Container App environment. And they share a single Azure File Share volume. A writer API accesses a JSON body containing a text string and saves it as a text file on the share. And a reader API lists and returns the most recent saved files. Okay, why this might be useful? Persistent durable storage. Container apps can scale to 0 and restart at any time. Files written to a mounted file share survive restarts, redeployment, and scaling events. Cross-service data sharing. Without a share volume, services must use APIs, queues, or a database. For file-based workflows, a shared folder is far simpler and faster. Lift and shift compatibility. Azure File Share speaks SMB. Many existing applications can be containerized without any code changes to their file I/O logic. And also cost efficiency. So it is built per gigabyte, and it is also cheaper than managing a database or managing a broker for passing the files around. Now let's see some of the use cases that can be used by this technique. For example, a processing pipeline where one service writes raw data and another reads and transforms it. Centralized log collection for multiple microservices, content management systems that stores the user uploaded files, batch job coordination without a message queue, and much more. I would like to show you the architecture of the application. So we are going to have two APIs. One of them is called Writer API and one of them is called Reader API, and they are running in the same container app environment, and they are basically going to use the share mount to access the files. The writer file is writing the file in the share, and also the reader one is reading them and returning them. So let's open the writer and see the code. Okay, I am in Rider, and in this project we have .NET Aspire, which is hosting our Reader API and Writer API if you are going to run it locally. And also if we go to the file system, there is a README file, which is basically describing how you can push and build your images in local machine, or if you don't want to build your images in the local machine, here is a command that you can directly basically push your images to the Azure Container Registry. And because of saving time, I already deployed the services in the Azure, but you can do it by yourself if you don't know how to do that. So back to the solution. Inside the Reader API, inside the Writer API, we have a simple program file, and here we can read the mount from the basically environment variable, or if it is not provided, the default one is this string. And here we have a post endpoint with the write route, which basically just saves the file inside the share. And also it has a payload, text payload, which gets just a string to keep it simple. For the Reader API, Also, if we go to the program file, we have there a read path, which is a get endpoint, and it just returns the recent files where we just uploaded them. Actually, nothing too fancy. So I'm going to run the project and we can see how it works on the Aspire dashboard. Okay, as you can see here, we have two APIs, Reader API and Writer API up and running. I am in Azure portal and I created already a resource group which is called RG Storage. And for saving the time, as I mentioned, I already created the resources, but I will walk you through them so you can understand what is going on. Again, nothing too fancy. And first of all, we have our container registry, and here I will show you the repository. Inside these repositories, we have two repositories, the Reader API and the Writer API, which our container apps are getting the images from. And also, this is our managed environment. It has two container apps, Writer API and Reader API. And here is our Reader API. There is nothing here yet, and also the Writer API as well. These are the things that I created. Also, we have an storage account, which I'm going to show you in a bit. So here, also, if we go to the classic file share section, there is no file share here, which we are going to create this together. I have created two endpoints, which we are going to test. Just a moment. And for example, these are the URLs anyways of our APIs. So for the read API, I already put here the URL. From this part you can get it, of course. This is the URL of our container app. And if now we send a request to the API, we will get that the mount is not exist. As you can see here, a mount path not found or not yet populated. And we are going to do this next. Okay, the first step is that I go back to portal, and inside our storage, I'm going to create a file share here. And we call it shared data. For the backup, we can disable it because we don't need it for the demo, and also here the create section. Okay, the file share is created and we can move on to our managed environment, because first we have to do it here. So inside the setting and volume mount, first we need to create a SMB block here. Okay, here at the name we call it shared data, and for the storage account name we can go back. Here is our storage account name. I paste it here, and we need the access keys, which we can find it from the security access keys. Show and copy this value. We go back here, and this is our share file share name, which I provide here. And also we would like to have a read and write access. I will add and then save it. Okay, we can move on to our Writer API. And here we need to go to the application section, volume, and we need to create here a volume. Let's call it shared data, and This is the shared data that we created in the environment, and we just add it. Now let's go to our containers. And in this section, we go to the volume mount and we press add. Here we choose our shared data and the mount path, which I am going to copy paste it from the code. If you want, you can have a different one and you can provide it in the environment variable of the container. So I just add it here and I will save it. It needs to redeploy the revision. It is created, and we need to do the same steps also for our reader API. So let's do that. Let's go to our application, volume, add. The file name. Okay, let's go to the containers. Go up, volume mount, press add, shared data, and the same path basically, and we just save it. Okay, it is created and it should be ready to go. We'll bring up now Insomnia so we can test our APIs. Let's go to the right, and if we try to send an empty text, we get an error. The text field must be not empty. Okay, makes sense. So we try to create something. Hi, this is a test text. Let's send this one, and we got the file written successfully. We can also create another one. Hi, for example, greeting from here, and send. Also created. And if we now test our read API also have the same file share. So basically it can read the uploaded files in the share. So I will send a request. And as you can see, we got 2 files, and this is the name of it, what time it was mounted, and the content of them. As we can see, it is listed here. Also, if we go back to portal, I would like to show you the file share. If we go here, inside our shared data, we can browse, and this is our newly added files through the API. I really do hope that you enjoyed this video, and hopefully see you in the next one. Until then, take care. Ciao.